Okay, so before we start, let me go back to the previous section 4.2. And for this problem, the very first problem that we did for the compound interest formula. Okay, so yesterday I said that this is the most important problem among the three problems about the compound interest formula. And let me write the calc just to indicate that this is, or similar to this problem, will be one of the calculator problems on exam 4. Okay, so this was one, or this is one of them. So like, don't expect the exact same problem to appear on exam 4, but similar problem like this will appear. Okay, and then also, we did this problem on the next page, which is about finding the world population. Okay, so I didn't mention this yesterday, but this is also a calculator problem. Okay, which means the similar problem like this will appear on exam 4. Okay, so remember I told you that there will be 5 problems that you absolutely must have to use calculator. Okay, so you saw one on the previous page, and this is the second problem, okay? And we will see a few others on the future sections, okay? And I will write down this like calc on those problems as well. Okay, so that's that. And then yesterday, so we saw these rules of logarithms, okay? So basically, when these two numbers are the same, basically it cancels everything and it's equal to 1. Now, if that number is equal to 1, then the answer is equal to 0, and you can just convert them into exponential form and see why that's the case. And then when you have this exponential form within the logarithm, you can pull out the exponent and put it in the front of the log, okay? And then when the logarithm is in the exponent and when the bases are the same, you can cancel them and it's equal to whatever is inside the log, which is m. And then the product within the log changes into the summation or addition of the logs. But if you have the division within the log, it turns into the subtraction of two logs, okay? And we saw why that's the case, which is these two rules in the exponents, okay? So let's work on some problems. Okay, so simplify or evaluate each log and try not to use a calculator, okay? So similar problems like these could appear on not just exam 4, but also on the final, okay? But the thing is, I will not use calculator on any of these, so you're expected not to use it either, okay? So part A, base 5, okay? So that's the base, right, remember? So base 5 log, and that's applied to 5. Okay, so what do you notice here? These two numbers are the same, right? Okay, so what does that mean? We have to use rule number 1, right? Because that's about the two numbers here are the same, right? And what does that mean? Log 5 is equal to 1. Okay, that's it. And now, log 10,000. Okay, so now this kind of problem can be tricky. Okay, and now notice that I didn't write the calc here. Okay, so log 10,000. Now here we see just log, and there's no subscript. Does that mean there's no subscript like ever? No, there is one, right? And what does that mean? This one is the common log, right? Okay, so this is the common log whose base is 10, right? Okay, so now, obviously, these two numbers are not the same, so the answer is not equal to 1, right? Now, however, are these two numbers related? Okay, appears so, right? So express 10,000 in terms of 10 to the some power. So what does that mean? It's 10 to the fourth power, right? Okay, so we just, count the number of zeros and we get 10 to the power 4. And now what can we do? So here we see the exponent within the log. So what does that mean? We can pull it out and put it in the front, right? Okay, and this is due to rule number, whatever, 3, I think. Okay, and this is due to rule number 1. Okay, so now, what is this? Log 10, 10. So because of the same reason as part A, it's equal to 1, right? Okay, so this is equal to 1. So what does that mean? 4 times 1, so that's equal to 4. Okay. So basically, what you will be seeing a lot of the times is writing this exponential form within the log so that you can pull the exponent out of the log. Okay, so that will be the crucial scheme. So in other words, using rule number 3 will be quite common. And now, part C. So part C is kind of written in a funny way, and that's because I didn't know how to write it in an alternate or different ways. But what I mean by this is ln and then e to the power 2/3. Okay? And now, here we saw yesterday what ln is. Okay? So ln. So first, there's no base. So the base is not like 2 or 3, right? And ln means what? It's the base e log, right? Okay, or the natural log, right? Okay, so we have log e, and then e to the power 2/3. And once again, you see the exponent within the log. So what does that mean? You can pull it out. So you have 2/3 log e, right? Okay, and now, what does log e mean? That's 1, right? Because these two are the same, right? So we have 2/3 times 1, which is equal to 2/3. Okay. And now, part D. ln of 1 over e squared. Okay, so here we see an exponent, which is 2. But what's the difference between C, the previous problem, and this D? So in C, we had just exponential form within the log. But here, we have a fraction. Okay, and the key thing here is the numerator is 1. Okay, so first, what can we do? Let's try to rewrite this 1 over e squared into e to the some power so that we have something like this. Is that possible? Yeah, right? 1 over e squared is what? E to the power -2, right? Okay, and so what do we have? ln e to the power -2, right? Okay, and now hopefully you can see what the answer should be. Okay, so again, if you don't see it, you can just do this. Okay, and what is ln e? ln e should be 1, right? Okay, now I didn't write it here, but from the previous problem, that is ln e, right? And we saw that's equal to 1, right? Okay, so ln e has to be 1, so it's equal to -2. Okay, and now log base 2, 16. Okay, so log base 2, 16. Okay, so now here, some people think the answer is equal to 8. Maybe, like based on my assumption, 16 is big and 2 is small, so they think, okay, 16 divided by 2, okay? Which is, yeah, legitimate reason, but that's wrong, right? Okay, so here, what do we do? Again, can you express 16 in a different way so that we have an exponential form within the parentheses? And here we want to write 16 in terms of 2, okay? Other than 2 times 8, remember exponential form. So 16 is what? 2 to the 4th power, right? Okay, so then we have log 2 and then 2 to the 4. Okay, and at this point, hopefully you know what to do. So what does that mean? These two are the same, right? And we have the exponent, which is 4. So put it in front. And then this log 2 will be what? 1, right? Okay, so it's 4 times 1, which is equal to 4. Okay, so once again, since a significant number of people tend to think this is equal to like maybe 8 or something else, okay, so this could be kind of a tricky problem. Now, next part. So here the base is now 1/3. Okay, which is kind of a weird base, but don't be bothered by that weird base. What is the key number here? That. Okay, no matter what your base is, whenever this number is equal to 1, what's the answer? 0, right? Okay, this base A can be any positive number other than 1, okay? So it could be 1/3, or it could be like square root of 2, okay? But all that matters is this number, and it's equal to 0. And this is due to rule number 2. Okay? And now, e to the ln, and be careful, it's not 32, right? It's 3 squared. Okay, it's not 32. So first, what do we do? So here, ln, remember, means base e log. So we have e to the log e, 3 squared. And now, was there any rules of log that deals with something like this? Like some base to the some power, that power has the log. And let's see. So it's kind of tough to see here, but if you look at rule number 4, it's about the mixture of the exponential form and the log, but the log is in the exponent, right? So here, what did we do? When these two bases are the same, a and then logs of a, they all cancel, and this thing pops up, right? Okay, so what does that mean here? All of these cancel, right? Okay, and due to rule number 4, this is equal to what? 3 squared, right? And what is 3 squared? 9. Okay. And now, part H. Log base 3, square root of 3. Okay, so here the two numbers are 3 and square root of 3. And are they related? Yeah, right? So yesterday we saw the conversion of the square root into exponential form. And hopefully you remember that, because I said that's quite important, right? So here, what do you do? Square root of 3 is what? 3 to the 1/2 power. Remember that? Okay. So what do you have? Log 3, and then 3 to the power 1/2, right? Okay, and hopefully at this point you can see what the answer is. So what do? Put the exponent out, and these two are the same. So what does that mean? It's just 1/2, right? Okay, so the reason that this kind of problem can be tricky is because people don't remember or don't know how to convert the square root or any other roots into exponential form. So in particular, like for example, if we had like cube root of 3, then we will have 3 to the power 1/3, right? Okay, so just keep in mind that you may see other roots, like other than the square root. Okay. Okay, so any questions on these simplifying logs? Okay, and again, remember that I did not use calculator on any of these problems. Okay, and I will, like I said before, I will show you what kind of calculator problems you are expected to see on the exam board. Okay, so now, number 5, expand each log as far as possible. Okay, so now, you will see another rules of logarithms here. And remember, we have used rule 4, and then rule number 3 right there. And then we used rule number 2 right there. And then we used rule number 1. So we have used the first 4 rules of log. And there are some rules that we haven't used yet. And what are they? These two, right? And now these 2 rules will appear here. Other than the first 4, like the first 4 rules will also appear here, but now the rule number 5 and 6 will come into play. And what does this question even mean? Expand each log as far as possible. Okay, so this problem means break down this log as much as possible. Okay, in other words, express the given log as sums or differences of multiple logs. That's what this problem means. Okay, so what does that mean? You cannot stop where you want to stop. Okay, or you may want to say, well, this one cannot be expanded. Well, you could see problems like that, but that's very rare. Okay, like 99.9% of the times, the given log will be able to be expanded, which means it will be able to broken down further apart. Okay, so here the key is sums and differences of multiple logs, and hopefully that reminds you why the rule number 5 and 6 have to come in. Okay, so part A, 2 times log 3 and then 7x. Okay, so remember, we have to see sums or differences. And at this point, we don't see any sums or differences. So you have to ask yourself a deeper question. What can I do to have sums or differences? So rule number 5 says, if we have a product within the log, we will see the summation. If we have quotient or division within the log, then we'll see subtractions. Now here, do we have, so here, it's quite obvious that we don't see any quotient or division, right? But here, do we see any product within the log? And it doesn't seem like there is, but there is one. And notice that 7x is the same thing as 7 times x. So there is a product, right? So what do you have? Due to rule number 5, it's log 3, 7 plus log 3x, right? Okay, so this is broken down into these two. And now, the next issue is, where is that 2? Is 2 just in front of log 37? No, where is 2? So yes, 2 is in front, but it's applied to where? To this quantity, right? Okay, because log 37x was broken down into log 37 plus log 3x, and 2 is multiplied in front, so that means 2 has to be present in front of the parentheses, right? Okay, it's not just applied to log 37, right? It applies to the summation. Okay, and now how do you clear parentheses? Well, at this point, there's no fancy rules of logarithms. What do you do? Just that, right? Okay, so we have 2 log 37 plus 2 log 3x. Okay, now here what you have to be careful is it's not log 314 plus log 32x. Okay, it's not this one. Okay, so this log 37 is like a number. Okay, and remember from yesterday's class, we saw that log can be a function, right? So this is like f of 7, and then this is like f of x. Okay, and it's obvious that when you distribute 2 times f of 7 is not f of 14, right? You don't write like that. It's just 2 times f of 7, right? Okay, and same reason. 2 times f of x is not f of 2x, right? It's just 2 times f of x. So it's this one. Okay, and at this point, there's no like terms. So some people think 2 log 3 is the like term, but okay? So 2 log 3 is not the like term. And the reason, or simple reason, is like when you have f of 7 plus f of x, you have 2f of 7 plus 2f of x, but you don't ever say 2f is the like term, right? That doesn't even make sense. Okay, so it's just 2 log 37 plus 2 log 3x, and that's the answer. Okay, and the thing is, this kind of problem gives trouble to most people, even if they know which rule to use, like rule number 5 and 6. Okay, so let's practice a few more. Can I go to the next page?
I do have one question.
Yeah.
So in the problems before, when we move the exponent to the front, does that not mean that 2 becomes an exponent of log 37 and log 3x?
That will come in on this problem. Yeah, okay. But here, when you try to expand it as much as possible, the coefficient must stay as it is, okay? So yes, whenever there's a coefficient, that can be turned into an exponent. But we actually go opposite. Whenever there is an exponent, we put it in front. And here, since 2 is already put it in front, we don't ever touch it. Okay? Yeah, good question. Now, part B. Okay, so now, hopefully you can see what to do because there are some exponents here. Okay, so we have log base 6 x cubed y over z squared. Okay, now by just literally looking at this expression, the very first thing that you have to notice is what? There's a fraction, right? Okay, so there's a fraction within the log. So what does that mean? Due to rule number 6, so fraction turns into subtraction, right? Okay, so what do you have? Log base 6. And now, what is the first term? So basically, if you look at rule number 6, what's at the top is written first, and then what's at the bottom comes second. Okay, so what does that mean? log 6, and then the top, x cubed y, and then minus log 6z squared, right? Okay? And now, is that it, or can we simplify further? We can go further, right? Okay, how? How? So let's look at this first log. Can that be broken down further? Yes, and what's the reason? X cubed y is same thing as what? X cubed times y, right? Okay, so we see a product, and that means due to rule number 5, the first log is equal to log 6 and then x cubed plus log 6y, and then we don't touch the last log, right? So log 6z squared. Okay, so this changes into this. And now, is that it? No. And now we have to go back to your question earlier, which is what? We see exponents. And where do we see exponents? Here and here. Okay. And now what do we have to do with the exponents? Pull them to the front of the log. Okay. So what does that mean? Now it's due to rule number 3, I believe. Okay. So take the exponent and put it in front. So we have what? 3 log 6x, right? And now here for the second log, we don't see the exponent, right? I mean, the exponent is 1, but what's the point of bringing down 1 and put it in front? And we have 1 times log 6y. It's same thing as log 6y, right? So we just keep the second log. And then for the last log, we have another exponent 2, and we put it in front. And now we only put this 2 in front of the third log, not to the very front, right? Okay, so what do we have? Minus 2 log 6z. Okay, and now, is that it, or do we have to go further? That's it. Okay, and what's the reason? So again, it seems like log 6 are the like terms, but this is kind of similar to 3x plus y minus 2z. And notice that I wrote things in a capital letters. Okay, and none of these is like terms, right? Okay, so even though we have the common thing log 6, that is not part of any like terms. So that's the answer. Okay. And now, part C, log 5 square root of 10 over 3. Okay, so notice that this is very similar with this one, the one before, right? The only issues are what? The base is not 6, and we don't see the variable, but we have a fraction. So what does that mean? Well, you can just use rule number 6, right? Okay, same thing that we did in the previous part. So what do we have? Log 5 square root of 10, and then minus log 3, right? Okay, and now, can we apply rule number 5? Or do we see the product within the log? Yes, and what's the reason? 5 square root of 10 means 5 times square root of 10. Okay, so we can use rule number 5 here. So we have log 5 plus log square root of 10, and then minus log 3. And now, are we done? No. Okay, it seems like we are done, but no, we are not done. And now, which log can be simplified further? This one. Okay. How? Because square root of 10, remember, is 10 to the power 1/2. Okay, so we have log 5 plus log 10 to the power 1/2 minus log 3. And now, what is this? So first of all, we see just the log with no base. So what's the base? 10, right? It's the common log, right? Okay, so here the base is 10. So what does the second log mean? First, you bring down the power and put it in front. And then log 10, 10 is 1, right? So what does that mean? Log 5 plus just 1/2 and then minus log 3, right? And now are we done? It's kind of a tricky question. And why? Because log 5 minus log 3, is that equal to log 2? And let's verify. Okay, so if you have a calculator, okay, so log 5 minus log 3. Okay, so log 5 and then minus log 3. Okay, so you get roughly 0.2218. And now, what is log 2? Do you get the same decimal? No. So they are not the same. Okay, and see, that kind of corresponds with my earlier statement where the same base log does not necessarily correspond to the like terms. Okay, so here it is. Okay, log 5 minus log 3 is not log 2. And hopefully you can see the reason. The subtraction in between the two logs turns into what? The quotient, right? Okay, so in particular, log 5 minus log 3 has to be equal to what? Log 5 over 3, right? Not log 2. Okay, so what does that mean? The answer is that. Okay, log 5 plus 1/2 minus log 3 cannot be simplified further. Okay, be careful. Log 5 minus log 3 is not log 2. It's rather equal to log 5/3. Okay, and now part D. Log 5, 2x plus 3y. Okay, so here we see the summation. So does that mean we will have the product? Because the summation means product, right? I don't think so. Okay, now, is it true that summation implies the product, or is it backwards? Product implies summation. It's backwards, right? Okay, do you see that? So here, be careful where the product is and where the summation is. So where is the product? Within the log. And where is the sum? In between the log. But here, what do you have? You have the sum within the log, right? Now, is there any rule that applies to the summation within the log? And the answer is no. There is no such rule, right? Okay. There are rules about product and quotient within the log, and sums and differences in between the logs, but not sums within the log, right? Now, people sometimes say, well, still you see the product here, 2 times x and 3 times y, so why can't you apply the summation of the two logs there, like here and here? Well, the thing is, this is the main operation in between 2x and 3y. So what does that mean? Is this equal to log 5 2x plus log 5 3y? Can you distribute log 5? No, because log 5, remember, that's not a number. It's like a function, right? So think about f of 2x plus 3y. Is this mean f of 2x plus f of 3y? No, right? That's false. So what does that mean? This is false as well. So what's the answer? Okay, it seems like you can distribute log 5 into 2x and 3y, but you can't. Okay, because think of this function. F of 2x plus 3y is not f of 2x plus f of 3y. Okay, and you cannot apply the rule number 5 on 2x and 3y because these two are joined by this summation. So first you have to take care of this summation and then apply rule number 5, but the thing is you cannot take care of this summation. Okay, so whenever you have a sum or differences within the log, you cannot simplify it. Okay, things can be simplified when you have product or quotient within the log, or sums and differences in between the logs, not within. Okay, so part D was kind of a trap question. Okay, so expanding the logs is important. Okay, then what is also important? Can you go back? Okay, that means if we are given something like this, 3 log 6x plus log 6y minus 2 log 6z, can you go back to log 6x cubed y over z squared? And the answer is yes. That appears in number 6. Okay, rewrite each into a single log. Okay, so this is the opposite of number 5. So what does that mean? We will see sums and or differences in between the logs, which we do here. And now what do you have to do? Combine them into a single log, something like this. Okay, so what do you have to do? Well, you can do the same thing, but now you have to apply the rules backwards. Okay, so first, part A, log 4x minus log 4y plus log 4z. Okay, so now here, if these are pandas, like for example, 4 minus 2 plus 3, what's the order? You go from left to right, unless you see parentheses, right? Okay, so you do this one first, right? So here, what do you do first? That. Okay, so first, log 4x minus log 4y. Okay, so we see the difference in between the two logs. So what does that mean? We have to use rule number 6, right? Backwards. Okay, backwards. So what does that mean? It will be log 4 and then x over y, right? Okay, again, this may look weird, but all I'm doing is just applying the rule number 6 the other way. Okay, difference in between the logs turns into the quotient within the log. Okay, that's all. So what do we have now? Log 4 x over y plus log 4z. And now we have the summation in between the logs. So what does that mean? Apply rule number 5, right? And again, backwards. So what does that mean? We need to multiply, right? Okay, so we have log 4 x over y times z, right? And now, is that it, or can we simplify this a bit further? So what is x over y times z? Can you possibly rewrite that further? Like, don't go back to the previous step. But what is x over y times z? How can you not see this product symbol? So if you think about like what happens when you multiply 2/3 and 4, what do? That and then that, right? Okay. So this means what? Log 4 xz over y, right? Okay, and that's it. And now, what's more important is on B, okay? Because unlike A, what do you see here? Some numbers in front, right? Okay, and we see sums and differences as well. So what do you take care of first? The summation? The difference? No, you take care of the coefficients first. Okay, so take care of coefficients. That must be the first step. Okay, now the question is, how do you take care of the coefficients? So remember, the coefficients become what? Exponents, right? And what's the reason? Due to rule number 3, right? Once again, backwards, right? Because remember, the rule number 3 said what? Whenever you have an exponent within the log, you can pull it out and put it in front, and that becomes the coefficient. So what do you have to do? Whenever there is some number in front, you have to push it back within the log, right? Okay, so what does that mean? First, the 4 ln r. So what does that mean? Ln r to the 4, right? Okay, you take the coefficients and you are sending it back within the log. And then 5 ln a becomes what? Ln a to the 5th, right? Okay, so what you have at this point is ln r to the 4th plus ln a to the 5th and then minus ln b. And now, is this similar with the previous one? Yes, right? And now, what do you do first? Go from left to right, right? So this time you do the summation first. So the summation means multiplication, right? So use rule number 5 backwards. So we have ln r to the 4th times a to the 5th minus ln b. And then the difference. So what does that mean? That turns into fraction, right? Okay, so use rule number 6 backwards here. So what do you get? ln r to the 4th, a to the 5th, and all over b, right? Okay, and this is kind of obvious, but apparently some people make this mistake. The top is not ra to the power 9, right? Okay, r and a are not the same basis, so you cannot add exponents, remember? So that's it. Okay, so again, recap, whenever there is a coefficient or the number in front, take care of that first, which becomes the exponent, and then apply rule number 5 or 6. If there is no coefficients, just like A, then you can go from left to right. Okay, so whenever there's a coefficient, you have to take care of that first. Okay, any questions on rewriting into a single log and expanding logs? Okay, so now we have used all of the rules of logs. And now let's look at the next problem. So given that log 7 is, okay, so now there is a weird symbol here that people say like squiggly equal sign. But what does that little symbol mean? And hopefully you have seen this symbol before because that's quite popular. What does this symbol mean? About or approximately equal to, right? Remember that? Okay, so the log 7 is not exactly equal to 2.8, but it's roughly equal to 2.8, right? And similarly, log 5 is roughly 2.3. So given those two numbers, find each without calculator. Part A, log 2, 35. Okay, so now, log 2, 35. So here, basically, what do you have? You have 7 and 5 within the logs, and then you have 35. So can you possibly produce 35 using 7 and 5? Yeah, of course, right? 35 is 7 times 5. Okay, so it's log 2, 7 times 5. Now, does that mean we need to multiply 2.8 and 2.3? Because we have a multiplication. No, be careful. You have product within the log, and what does that mean in terms of each individual logs? You have to add, add, right? Okay, be careful, you are not multiplying 2.8 and 2.3. It's product within the log, so that means the summation of each individual logs. So what do you have? 2.8 plus 2.3, right? Okay, and now hopefully you remember how to add decimals by hand. Okay, so what do you do? 2.8 plus 2.3, and so it's what? 5.1, right? And now, log 2, 7 over 5. Okay, does that mean 2.8 over 2.3? No, remember, fraction within the log means what? The difference, right? Okay, so it's log 7 minus log 5. So this means what? 2.8 minus 2.3. And what is this? 0.5, right? Okay. And now, log 49 over 25. Okay. So now, at this point, we don't see 7 and 5 right away. Are we in trouble? No. So it seems like we can get 49 from 7 and 25 from 5, right? Okay, how? So first, 49 over 25. What does that mean? It's 7 squared and 5 squared, right? Okay, and this alternately means 7 over 5 entire thing squared. Oh, so we have an exponential form within the log. Does it remind you one of the rules that we can use? Yeah, so what do? Take the exponent and put it in front, right? So you have 2 log 2 7 over 5, right? Okay, and now, what is log 2 7 over 5? Well, we just got it in part B, right? It's 0.5, right? So we have 2 times 0.5. And 0.5 means what? 1/2, right? And you're multiplying by 2 in front, so what's that equal to? 1, right? Okay, again, be careful. I didn't say log 249/25 is equal to 1. You know that's false, right? Because that has to be equal to 2 so that we get 1, right? But how is that even possible? Well, because it's actually this, right? Okay, so log base 249/25 is approximately equal to 1, not exactly equal to 1, right? Okay, but I mean, here, like 1 is fine because these two were approximations anyways. Okay, so that's that. And now the last concept of the section is another important formula. And here comes another calculator problem. Okay, but first, change of base formula. So basically, when people invented the logarithm, like many years ago, like maybe more than 1,000 years ago, people back then didn't have calculators. There was no technology. All they had was their brains, hands, and eyes. Okay, so at that time, like in the early stages of log, people had the common logs and then the natural logs. There were no other base logs. So they kind of questioned themselves, can we express any base log in terms of common log and natural logs? And then they came up with this formula. Whoever came up with this formula, he or she was super genius. Mundane person like me cannot even come up with this formula, but hopefully some of you or all of you can come up with some major discoveries in math in the future. And when you win some kind of award, please mention my name. Okay? Yeah. Of course, like I'm not trying to take away any credit from you, but I don't know. Anyways, so log base AB. Okay, so this is equal to ln B over ln A. Okay, so we have the natural logs. Okay, so here, what do you notice? So there's a fraction and the bigger number B goes to the top. Now here, bigger does not mean like bigger in terms of the magnitude, but here it's the bigger font. And then the smaller font A goes to the denominator. Okay, so ln B over ln A. Now, can we have the common logs, log B and log A? And are these two fractions equal? They don't seem equal to each other, but surprisingly, they will be the same. And you'll see why once we do these problems. Okay, so here we have the common logs. Okay, and then here we have the natural logs. Okay, so let's look at these final two problems. Use the change of base formula to approximate each up to 4 decimal places. Okay, so be careful with these instructions, not only on the homework, but also on the exam form. Your homework may say, round your decimal up to maybe 2 decimal places, or 3, or maybe 4. Okay, I don't know. So be careful with these extra instructions. Okay, so log 4 2.345. So by the change of base formula, this is equal to what? ln 2.345 over ln 4. Okay, or you can say log 2.345 over log 4. Okay, either way, and you'll see that it doesn't really matter here. So just type in ln 2.345. So ln 2.345, and then you divide it by ln 4. Okay, so you get this decimal. And just to verify, try to use the common log. So log 2.345 divided by log 4. You get the same decimals? Oh, yes. Okay, so using which special logs doesn't matter. Okay, so how should you write your answer here? It says round to the 4 decimal places. So that means the rounding takes place from 9, right? So what's the approximate answer? 0.6148, right? Okay. And now, log square root of 3 and then 17. Okay, so here again, we see some weird base, the square root, but that's fine. Because as long as your base is positive other than 1, it can be any number. So this is equal to what? Log 17 over log square root of 3, right? Okay. Or you can use ln 17 over ln square root of 3. It doesn't really matter. So what is this equal to? So log 17. So log 17 divided by log and then square root of 3. So that means just do the square root and then 3. Okay, so you should get 5.157803 and so on. And up to 4 decimal places, so what does that mean? 5.1578, right? Okay. Okay, so again, this problem is another calculator problem. And keep in mind that you may see negative number as the answer. Okay, so depending on what kind of log you have, your answer could involve the negative sign. Okay, but don't be panicked, that is quite normal. Okay. Okay, so any questions on these problems? Okay, so now you have seen 3 types of calculator problems, and now there are 2 more, which comes on the next section. Okay, so now 4.5. Okay, so now here we will see exponential and log equations. Now, in previous 3 sections, 4.2, 4.3, and 4.4, we saw quite basic exponential log equations. And now, here we will see not so basic. Well, that doesn't mean it's like super hard, but it's kind of different, I should say. So let's look at the exponential equation case. In 4.2, we had basic exponential equations, which meant the bases were related. Remember that? Okay, so now, what does this mean? So for example, we had something like this. Okay, and here, what are we looking at? We are looking at these 2 numbers, right? 2 and 16. And we saw that they were related. How? 16 was 2 to the 4th, right? Okay, so what do we want? We want the same basis, right? And then once we have the same basis, we set exponents equal to each other. Remember that? Okay, now, what if the bases are not related, such as 2 to the x is equal to 3? Okay, 2 to the some power is not ever equal to 3, and it's different from, you know, something like this, right? Okay, like we saw this kind of equation as well. So what does that mean? 27 is not 9 to the some power, but both of these numbers come from the same number, which is 3, right? So we wrote 3 cubed and then 3 squared for 27 and 9 respectively, right? Okay, but we cannot have such thing here either. So what do we do? Well, that's why we need this separate scheme. So here is the scheme to solve. Now, before you go any further, what you have to check is isolate the exponential expression by itself on one side. Okay, so this means like 2 to the power x, that is isolated by itself. Okay, so if you have like maybe something like 3 times 2 to the x is equal to 4, then it's not quite isolated because 2 to the x is not by itself, so you have to divide by 3 until you get the isolation. Okay, so you have to do something like this so that you have the isolation of exponential expression. Now, if you have that, you take the ln to both sides. Okay, and here the thing is you can also take the common log. So you take ln or log to both sides. Now, which log is more common? Ln is more common. Okay, so I will stick to the natural log instead of the common log. But because of the change of base formula that we just saw, you can also take the common log and get the same answer. But ln is more popular. Okay, so we take the natural log to both sides. So what does that mean? So let's take this simple problem, 2x is equal to 3. Okay, so for example, we take ln 2 to the x is equal to ln 3, something like this. Okay, and now, what is the convenient thing of taking the ln to especially this left-hand side? Oh, we see exponent here. Does it remind you anything? Any rule? Rule number 3. Bring down the exponent and place it in front of the log. So what does that mean? Do that. Okay. And then use algebra to solve. So what does that mean? Here, algebra means distribution or division or combine like terms. Now, for this problem, it's quite simple. So we only have to do the division. Why? Because if we look at this equation carefully, we have x times some number is equal to some other number, right? Okay, so how do you isolate x? Just divide by what's behind x, right? So what do you do here? Divide by ln2. Okay. So the last step can be tricky, but every other step is quite straightforward. Okay, so in short, we use what? Logarithm to solve exponential equations. Okay, so what does that mean? Can you guess how we will solve log equations then? We will use exponential form. So what does that mean? They help each other and they need one another. Okay, to solve exponential equation, we need log. To solve log equations, we need exponential. Okay, so We will see log equations in the next part, but first we want to do the exponential equations. So part one, solve. Give an exact answer in terms of ln, and then round to the nearest thousand as needed. Okay, so here, if you look at this problem carefully, there are two parts. Number one, exact answer, and number two, approximations. Okay, so part A, 8 to the power x is equal to 21. Now here, do we divide by 8? Please don't, okay? It's not 8x equals 21, right? It's 8 to the power x, okay? So we have to go through these steps. So step number 0, do we have the isolation of exponential term by itself? Yes, right? A to the x is by itself, right? Okay, so this one is already isolated. Oops, isolated. So that's good. And now, what do we do? Take ln or log to each side, but I use ln. So what does that mean? So we take ln to each side. So we have ln a to the x is equal to ln 21. Okay, and now what is step number 2? Bring down the exponent and put it in front of the log. So what do we have? So we have x ln 8 is equal to ln 21, right? Okay, and now use algebra to solve. So look at this equation carefully. X ln 8 equals ln 21. How can you isolate x? You have to somehow remove ln 8, right? And what's the only way to remove? Divide, right? Okay, so divide both sides by ln 8. So what does that mean? Over ln 8, over ln 8. So these two cancel. So x is equal to ln 21 over ln 8. Now here, can we cancel the ln's and get 21 over 8 as the answer? No. Okay, please don't. So that is the answer, and this is the exact form. Okay, and as you can see, this one is written in terms of ln. Okay, so that's the exact form. And now, how do you approximate this into the nearest thousand? So first of all, nearest thousand, what does that mean? So thousand means 3 decimal places, right? So we need to write our decimal up to 3 decimal places. Okay, so how do you get the approximation? Well, use your friend calculator. Okay, that's the only way to get the approximation, right? Okay, so type ln 21 over ln 8. So ln 21 over ln 8. Okay, so you should get 1.464105 and so on. Now up to 3 decimal places. So that means what? 1.464, right? Okay, so 1.464. That is the approximation. Okay, so when you do your homework or even the exams, be careful with these possible extra instructions. Your problems could say, write the exact answer, or it could say, round your decimal up to 3 decimal places or 4 decimal places or whatever. Or it could also say, write the exact answer and write the approximation up to several decimal places. Okay, so look at the possible instructions. And this is the fourth calculator problem. Okay, I'm just giving out all the problems. Like, I don't know how I'm doing that, but I don't know. Whatever. I'm just too nice. So part B, a to the power x is equal to negative 21. Okay, so it's very similar with the previous part. What's the only difference? The negative sign. Will that make difference? Well, you'll see. So here first is the a to the x isolated. Yeah. So what do you do? Take ln, right? Okay, so exact same thing. So we take ln. And so we have ln a to the x equals ln negative 21. And then what do you do? Bring down the x. So you have x ln 8 equals ln negative 21. And then what did we do earlier? Divide by ln 8, right? So exact same thing. Okay, so x is equal to ln negative 21 over ln 8. Okay, so that's the exact answer, right? So put this into your calculator. Okay, so ln negative 28 divided by ln 8. And now, what do you see? Do you see something funny? If you see some decimal, then maybe you type something wrong, okay? But you should see an error message, okay? So here it says domain error. If you use the graphing calculator, I think you'll see non-real solution or non-real answer, okay? But this one is an error. Oh, why? What's the reason? Okay, so here is the reason, which you don't have to know, but I'm just gonna tell you why this one caused the error. Okay, so last time we had this fact. Remember that? So you don't have to write this reasoning here because you don't have to know it. That's the conversion of log into exponential form, right? Remember that? The base goes to the base and then the result becomes the exponent. And now, let's swap x and y. Okay, so we get a to the x is equal to y. Okay, and a to the x, that is the exponential function whose graph is what? This or this, right? Depending on what happens to the base. Now, what is the range of this exponential function? The range is all positive y values. So that means y is positive. Okay, so now, where was y? It's this one, so that guy has to be positive. Now, remember, we swapped x and y, so what has to be positive? X has to be positive, right? And so, go back to one step before. That guy has to be positive. So what does that mean? Whatever you have within the log, that needs to be positive. And do you see why this one caused the error? That is illegal. Okay, so this is illegal, which is why it caused the error message. So what's the answer then? Just error message? No, what's the answer? Okay, so here I have to say no real number solution. but it actually means no solution. Okay, so be careful. You cannot have negative number inside the log. That will appear when we cover the log equations. Okay, so that's B. And then C. 1.2 and then times 0.9 to the x is equal to 0.6. Okay, so now here, do we have the isolation of exponential term? No. And what's the reason? 1.2 in front, right? Okay, so how can you remove that 1.2? Divide by 1.2. Okay, so divide by 1.2. So what do you get? Just 0.9 to the power x, right? And what is 0.6 over 1.2? So you can use your calculator, or you can just get the answer because this is not a hard fraction, but you should get 0.5. In other words, 1/2. Okay, and then what do you do? Now you can take the ln to each side. So you get ln 0.9 to the x is equal to ln 0.5. And what does that mean? Bring down the exponent. So you have x ln 0.9 is equal to ln 0.5. And then what do? Divide by ln 0.9. Okay, so divide by ln 0.9, ln 0.9. So what do you get? X is equal to ln 0.5 over ln 0.9. Okay, and that is the exact form, right? Remember that from part A? And now can you get the approximation from here? Yeah, so what do? Just put in this number into the calculator, right? Okay, so approximation. What is the approximation? So ln 0.5. Oops, okay, there we go. Okay, there we go. ln 0.5 and then divided by ln 0.9. Okay, this time we don't see any error, so that's a good sign. And so we get 6.5788, but remember we have to round up to 3 decimal places. So what's the answer? It's 6.579. Okay. Okay, now part D. So this will be the final calculator problem. I mean, something like this, like not exact same problem as this, but something like this. E to the x squared equals 50. Okay, so now here, what is the exponent? The real exponent. Is the real exponent 2? No. What's the real exponent? X squared, right? Okay. And now, here, do we have the isolation of exponential term? Yes. Okay. So what do? Just take the ln right away. Okay, so what do you get? ln e to the x squared equals ln 50. Okay, and then you bring down the exponent, right? Now here, does that mean you only bring down the 2? No, you bring down what? X squared, right? Okay, bring down x squared. Not just 2, right? So you get what? X squared ln E is equal to ln 50. Okay, and now you divide each side by ln E, but before you do that, what is ln E? Have we seen this before? Yes, ln, remember, is base E logarithm, right? So ln E is what? 1, right? Yeah, so we have just x squared equals ln 50. Okay, so how do you get x by itself? You take the square root, right? So square root, square root. So x is equal to square root of ln 50, right? Right? X is equal to square root of ln 50. Are we forgetting something? That, right? Okay, please don't forget plus minus. Okay, so what's the exact answer? Plus minus square root of ln 50. That's the exact answer. And so what is the approximation? Well, just type square root of ln 50 and then round up to 3 decimal places. So ln 50 or square root of ln 50. So square root of ln 50. And so what do you get? 1.978, right? After rounding. So what's the answer? Plus minus 1.978. That is the approximation. Okay. And again, this is the last calculator problem. So I have given you, or even better, I let you know what kind of calculator problems are expected. Okay. And for every other problems, you must not use calculator. Okay, be careful. Okay, so now for the last two problems of the exponential equations, these are only for the homework, okay, because they are kind of tricky. 2 to the x plus 3 equals 5 to the 2x. Okay, so now here, what's the issue? We have two exponents, right? Okay, and x is on both sides, not just on one side, right? Okay, and moreover, the two bases, 2 and 5, are not related. Okay, so now, step number 1. Do we have isolation of exponential terms? Okay, not all together, but let's look at the individual exponential expressions. Do we have the isolation for each individual? Yes. Okay, so let's go to the step number 2 right away, which is take ln. Okay, so what do we have? ln 2 to the x plus 3 is equal to ln 5 to the 2x. And now, what can you do? Move the exponent, right? But here, what do you have to do? Bring down the exponents. Okay, not just one, right? So you bring down these two exponents and put them in front of each log. So what do you get? X plus 3, that quantity, times x plus 2 is equal to 2x and then ln 5, right? Okay. And now things become quite tricky. What do you do next? So what seems to be the next step? Again, this one is kind of tricky, but at least this first step is not that hard. What do you want to do first? So here my hint is, this is quite similar with this problem. Okay, so for now, forget about the ln, but this is really similar with this problem. What would you do next? That, right? Okay, clear parentheses. So here, what do you do? What do you distribute? ln2. Okay, so here you distribute ln2. And now, what do you get? You get x ln2 plus, do you get ln6? No, it's just 3 ln2. Okay, be careful, it's not ln6. And now, what do you do next? So from here, once you distribute 2, you get 2x plus 6 equals 2x times 5. Okay, now here, there's a reason that I didn't write this right-hand side as 10x. Okay. Now what do you have to do? Get x's on the same side, right? So here you what? Subtract 2x, right? Okay, that's what you do here. So then what do you do here then? Get x's on the same side. So here you have, or you can move 2x ln 5 to the left-hand side or x ln 2 to the right-hand side, but what is better? X ln 2 to the right-hand side is better, right? Because you have this number on the left-hand side. Okay, so subtract x ln 2. Okay, so you have 3 ln 2 is equal to 2x ln 5 minus x ln 2. And now there are only 2 more steps. What's the next step? So from here in this easy problem, you have 6 equals 10x minus 2x. Now, what does that mean? 6 is equal to 8x, right? And now, let me ask you this. Why is 10x minus 2x equal to 8x? Why? What's the reason? Then people say, well, 2 minus 2 is equal to 8. And then I say, well, what happened to x? So here, what is the hidden step that most people choose to skip? This one, right? Take out x. Okay. So x is not affected, which means we take it out and then we subtract 10 minus 2, right? So what do we do here? Take out x. So we have 3 ln 2 is equal to 2 ln 5 minus ln 2, and then parentheses times x. And then hopefully you see what to do. So here you divide by what's in front of x, which is 8, right? And so here, what you do is divide by 2 ln 5 minus ln 2. So you have 3 ln 2 all over 2 ln 5 minus ln 2 is equal to x. And that is the exact form. Tricky, okay? But it's meant to be tricky, so that's okay. Now, what is the approximation of this? So, to get the approximation, you have to plug in this fraction onto your calculator. Now, when you do that, be a little bit careful, because if you just do 3 ln 2 and then divide it by 2 ln 5 and then minus ln 2 like this, okay, when you type your fraction like this, our stupid calculators think what I mean is 3 ln 2 over 2 ln 5 and then you subtract ln 2 in the back. Apparently calculators cannot read our thoughts, so we have to be rather specific. Okay, so how can we specific? Put parentheses around the denominator. Okay, so what does that mean? From here, you put parentheses, division, and then you put parentheses, and then 2 ln 5, and then minus ln 2, like this. And then you have to close your parentheses once again. Okay, so you get 0.823 after rounding. So that's the approximation. Okay, yeah, there is a reason that why that this problem is quite tricky. In fact, this is the trickiest problem in this exponential equation case. The last problem is not too bad. It's much better than the previous part. So here, do we have the isolation of exponential terms? Not quite. Can you possibly rewrite the left-hand side into one exponential form? Yes, because what do you notice here? The two bases are the same. So what does that mean in terms of the exponents? You can add them, right? Okay, so step number 1, add exponents. Okay, so what do you have? E to the 1 minus 3x plus 5x is equal to 2e, which means e to the 1 plus 2x is equal to 2e, right? Okay, then we have the isolation of the exponential term by itself. Now, here there is another issue, which is what? We have e's on both sides. So in particular, can you possibly move this right e to the left e? And what's the only way to move the right e to left e? You have to divide. Divide both sides by e. Okay, so divide by e like this. Then what happens? E to the 1 plus 2x all over e is equal to 2, right? Okay. And now, how can you possibly rewrite this left-hand side into just one exponential form? Okay, so as an example, a5 or a to the 5th power over a cubed, that's equal to a squared, right? And how do you know it's a squared? You subtract the exponents, right? 5 minus 3, right? So can you do the same thing here? Yes. So e to the 1 plus 2x over e is, so the bottom exponent is 1. So what do we have? E to the 1 plus 2x and then minus 1. And something nice happens, right? We just have e to the 2x. Okay, so we have e to the 2x is equal to 2. Okay, then we have the real isolation of exponents on the left-hand side. So now we take the ln. So we have ln e to the 2x is equal to ln 2. Oops, ln 2. Okay, and then what do? You bring down the exponent, right? And so you have 2x, and then ln e equals ln 2. But remember, ln e is 1, right? So you have 2x is equal to ln 2. So by dividing by 2, you get x is equal to ln 2 over 2. Now, here, can you cancel the 2's? No, okay, because the up to is within the log, right? So yeah, please do not cancel. So that's it. And that's the exact form. And so what's the approximation? Just punch in this number into the calculator. So ln 2 divided by 2, and by rounding up to 3 decimal places, we get 0.347. And that's the approximation. Okay. Okay. So again, we saw some tricky problems here, but don't focus too much on the latter two problems. Just focus on the first 4. Okay, so those are the key important problems. Any questions over these exponential equations? Okay, so now let's look at the log equations. So as I said earlier, when we use exponential when we solve exponential equations, we use the log. So to solve log equations, we will use exponential form. How? Well, here's the scheme. So number 1, if necessary, isolate the log expression by itself on one side. Well, that looks similar, right? In the exponential case, we have to isolate the exponential term. Here we have to isolate the log expression by itself on one side. Now, here, how many log or logs do we have on one side? 1. And how do we know it? The log. Okay, isolate the log expression by itself on one side. Oh, well, what if you have multiple logs? Then what you have to do is combine them into a single log. How is that even possible? Well, we have looked at 2 rules that matter, which are what? Whenever you have summation in between the logs, that means what? The product, right? Within the log. But if you have the difference or subtractions, difference of logs, that turns into what? Fraction, right? Remember that? Fractions in the log. Okay, so that's what I mean by combining. So rule number 5 and rule number 6. And then we write it into, so at this point, after step number 1, we have something like this. Log AM equals R. Okay, so we just have a single log, and then we have a number on the right-hand side. So what can you do here? We can convert this into exponential form. And solve. So what does that mean? If we have log AM equals R, this means what? So base goes to the base, and then the result, which is the exponent, which is R, and that's equal to M. Something like this. Okay, and then you solve it. Now, normally when you solve, you are done, but not for the log equations. So this is the important step. Plug in the values from the previous step into x in the original equation. Okay, and then throw out values that give negative numbers inside the log. And what's the reason? Because we just saw in number 1 part B here, you cannot have negative number within the log because that's illegal. Okay, so that's why you must go through this screening process. Okay, so please don't forget this extra step. And now, here is my suggestion though. If you get a single value after step number 2, so that means one number, then in general, you don't have to plug in this value into the original x, because in 99.9% cases, that will be the answer. So this screening process is mandatory when you get 2 or multiple x values. Okay, now the thing is, this is in general like not true, but in your problems, you won't see any of those like weird cases. Okay, like on the homework or on the exams. So, okay, so now let's look at these problems. So, give an exact answer, not approximations. Okay, so now approximations are not allowed, and you will see why. So, part A, 4 ln x is equal to 36. Okay, so now, first one, step number 1. Do we have just one logarithm on one side? Yeah. Is it isolated? 4 ln x. Is it isolated? No, not quite. Because of what? 4 in front, right? Okay. So how do you remove this 4? Divide it, right? Okay. So step number 1. Divide by 4. Okay. So what do you get? ln x is equal to 9, right? Okay. And now step number 2. Convert this into exponential form. And what does that mean? We just use this fact, right? Base goes to the base and then result becomes the exponent thing. Okay, so let's convert this into exponential. So what do we do? So here the base is e, right? Okay, so the base goes to the base. Okay, so base is e, which goes to the base. And then what is the result of the log? 9, right? And that becomes the exponent. Okay, so what do you have? E to the power 9, and then the remaining thing equals x, right? Okay, now, how do we solve this? So what does that mean? How do we isolate x? Is x already isolated? Yeah, right? And what do we have as the other side? E to the power 9, right? Now, do we need to plug this into the calculator? No. And what's the reason? Exact answer. Okay, so this is the exact answer. If we plug this into the calculator, you'll see some decimal, but that's just approximations. Okay, so this is the exact answer. And in fact, that is the answer. Why? We got one number as the x value. So you don't have to go through the screening process. So that's it. Okay, so once you know the scheme, it's really simple, right? If you don't know it, then it's not that simple. But here it's quite simple. Now, part B. ln 2x is equal to 5. Now, here, what does ln 2x mean? Does that mean ln 2 times x or ln of 2x? Which one is it? Is it the first one or the second one? It's the second one. Okay, so this means, yes, ln of 2x is equal to 5. Okay, not ln 2 times x. Okay, it's ln of 2x. Now, do we have one log on the left-hand side? Yeah. Is it isolated? Yeah. So what do? Convert into exponential form. Okay, so base goes to the base and things like that. So convert. So what does that mean? We have log base e and then 2x equals 5. So base goes to the base, which is e. And then what's the result? 5, right? And then the remaining thing equals 2x, right? Okay, and now x is not isolated, so what do you do next? Divide by 2, right? Okay, so we get what? E to the 5th power over 2 is equal to x, right? Okay, and remember, this is the exact form. Okay, and we only got one number, so that's the answer. Okay. Okay, so now go to the next page. So we have log base 3 x cubed minus 5 is equal to 1. Okay, so now step number 1. Do we have one logarithm on the left-hand side? Yeah. Is it isolated? Yeah. So now the first step, convert. Okay, convert into exponential form. Okay, so what do? Base goes to the base, which is 3. And then the result of the log, which is 1, right? And then the remaining thing, x cubed minus 5. And now, what is 3 to the power 1? 3, right? Yeah, okay. So 3 is equal to x cubed minus 5. And then what do? Add 5, right? Okay, so you get 8 is equal to x cubed. And now, how do you remove the power 3? What's the only way? Cube root, right? Not square root, remember, because of the power 3, right? Okay, so x is equal to cube root of 8. Oh, what is cube root of 8? Is that a nice number? 2, right? Yes. Okay, so that's equal to 2. And we only got one number, so that should be the answer. Okay. Now, part D. Okay, so now problems like this will be, I wouldn't say hard, but it's important and trickier than the previous three. Now, on the left-hand side, how many logs do we see? Do we see one logarithm? No, we see two, right? Okay, so what does that mean? We have to somehow combine them into a single log. And is that even possible? Can you combine the left-hand side logs into a single log? Yeah. Now, what kind of symbol do we see? The addition, right? Does it remind you any rules of log that we have to use? So, first we combine the logs. And what can we do? The summation between the logs, and that turns into what? Product, right? Okay. Inside the log, of course. Okay. So what does that mean? Here, what are we multiplying? Log 3x plus 5 and log 3x minus 3? No, what are we multiplying? X plus 5 and x minus 3, right? Okay, not these entire logs, but what's in the logs can be multiplied, right? Okay, so what does that mean? We have log 3, x plus 5 times x minus 3, and that's equal to 2. Okay, it's this one. And now what do you do? So here, there can be two steps that you can take, but most people choose to FOIL. Next, FOIL what? This one. Okay, so what do you get? Log 3, and then you get x squared. And now here I will skip a step. Minus 3x plus 5x. So that is what? Plus 2x, right? Okay, and then minus 15 is equal to 2. And now we have just one logarithm, right? Is it isolated? Yes. And now what do you have to do? Convert. Okay, so now you have to convert into an exponential form. So base goes to the base, which is equal to 3. The result, which is 2, so that becomes the exponent. And then is equal to x squared plus 2x minus 15. So many people say x squared plus 2x minus 15 is equal to 2, okay? Not 3 squared, and then they get wrong answers. Okay, so don't forget to convert like this. And now, what does this mean? That's 9, right? And this is a quadratic equation, so what do you do? Make one side equal 0. So x squared plus 2x minus 24 is equal to 0, right? Okay, and now you solve. So now, can you factor the left-hand side? Yeah. So what times what? Let's see, negative 4 and 6, right? So x minus 4 times x plus 6 is equal to 0. Okay, so x is equal to what? 4 and negative 6, right? Now, are we done? No, not this time, right? Because why? We didn't get one number for x. So what do we have to do? Check, right? So you must check. And remember, how do you check? You plug 4 and negative 6 into the original x. Okay, plug in 4 and negative 6 into the original x. So start with 4. So what do you get? Log 3 and then 9 plus log 3, 1 is equal to 2. Now remember, why do we check this? Because what we don't want to see is what? The negative numbers within the log, right? So what does that mean? If we don't see any negative numbers within the log, we are good to go, right? Okay, so what do you notice here? Do we see any negative numbers within the log? No. Okay, so that's good. So 4 is unanswered. Okay, now check negative 6. So what do you get? Log 3 and then negative 6 plus 5. So what does that mean? Negative 1, right? Now, the neat thing about this checking process is if you get a negative number within the log somewhere, you don't need to go further. In fact, I don't care what happens for the other logs. We may get negative number, we may not. Why? This is already bad, right? Okay, this is bad. So what does that mean? This is not good, so negative 6 is out. So what's the only answer? 4. Okay. Another misunderstanding that people make is, oh, so negative number is always out and positive number always works. And that is also not true, okay? It could be the opposite. It could be both numbers might work, both numbers might not work, okay? You never know. So you must check explicitly, okay? Okay, any questions on these log equations? Okay, so now, before we do the next set of problems, let's do this problem, or let's do this fact first, which looks quite obvious. So log base an is equal to log base an. Okay, so here the two bases are the same. Now, what do you want to do before I tell you the conclusion? So log an is equal to log an. So what seems to be the conclusion?
M and N are equal.
M is equal to n, yes. Cancel the log a's right away. Okay, now why do I even mention this kind of stupid looking fact? Well, because look at the next problem. Again, it's the exact same problem, give the exact answer, not approximations. Now we have log 2x plus 1 plus log x is equal to log x plus 8. So compare this problem with the one before. Do you see the difference? In the previous problem here, we saw how many logs? 2, right? And now here, how many logs do you see? 3. Okay. So does that mean the steps need to be changed? No. We just look at the left-hand side and see if we have to combine logs. And what do you notice here? We do have to combine them, right? Because we don't have a single log. Okay, so what do you do? Well, we see again the summation, right? So what does that mean? The sum turns into the product. Okay, so step number 1, combine the left side logs. Okay, so again, the sum turns into the product. So what does that mean? Log 2x plus 1 and then times x is equal to log x plus 8, right? Okay. And now what do you do? And now you can clear the left-hand side parentheses. And what's the only way to clear left-hand side parentheses? Distribute x, right? Okay, so you get log 2x squared plus x is equal to log x plus 8. And now, can you see what to do? Okay, so in the previous problem, we converted into exponential form, but here, do we have to do that? No. What can we do? Cancel the logs, right? Why? Because both have the same basis. And by the way, what are their bases? 10, right? The common logs. Okay, so that. Okay, so what do you get here? 2x squared plus x is equal to x plus 8. Okay, so now what do you do? Make one side equal 0. So minus x minus 8 minus x minus 8. So that is 0. Okay, and what is the left-hand side? 2x squared minus 8 is equal to 0, right? Because x minus x also cancel. Okay, so what do you do here? So now how do you solve it? Plus 8 and then divide by 2, right? Okay, so plus 8 and divide by 2. So what do you get? 2x squared is equal to 8. Divide by 2, so x is equal, or x squared is equal to 4. And so what do you do? It's square root. So x is equal to 2, right? Plus minus. Yeah, don't forget plus minus, right? Now, are we done? No, because we got two numbers, right? So that means we must check. Okay, so plug each number into the original x. So start with 2. So what do you get? Log 2 times 2 plus 1. So that's what? 4 plus 1, so that's 5. And then plus log 2 is equal to log 10, 2 plus 8. Well, all of these are positive numbers. So that looks good. And now, negative 2. So log 2 times negative 2 plus 1. So that means what? Negative 4 plus 1, so that's negative 3, right? Uh-oh, that doesn't look good because that is negative, right? So what does that mean? We don't need to plug in negative 2 on any other x's. This is already bad. So negative 2 is out. So what's the answer? 2 only. Okay. Okay, so let's see. That is part A. And now it's already past noon and we have about 2 more problems to go, and then we have some other problems. So yeah, I guess I'll stop here and then we'll come back tomorrow and then remind you like these rules of logarithms and what to do on these equations. But so we only have like 5 more problems to go within this section, and then we will go to the next section, okay, which is not that long. It only has like 5 pages, okay? So tomorrow, the plan is we will finish lecturing everything, okay? So this is the second section from the last, and then tomorrow we'll finish up this section, and then we will do the last section. And then for the remainder of the class tomorrow, I guess I will just ask you some questions and just to see if you have any concerns or questions from any of the course materials. So it will be more like Q&A session for exam 4 and or the final exam. And my goal is to reserve or to have some kind of like review session or Q&A session for your final exam, maybe I guess Monday. So like I said on the email yesterday, like what I'm not so sure is when the grade submission is due. So if the final exam is, or if the grade submission date is sometime on Tuesday, then I guess what I'll have to do is give the first time slot of the final exam to be on Monday night at 10 o'clock. And then I will give the 2 other time slots on Tuesday morning and in the afternoon so that I can submit the grade like within or before Tuesday midnight. But if it's due Wednesday morning, then I can just give you final exam on Tuesday only. And then the downside for that is, for those who plan to choose to take the final in the night at 10 o'clock, you will have very limited window to check your course grades. Okay, so the thing is, before I go to bed on Tuesday night, I will set all the course grades and then submit it. But the thing is, I normally give people to check their course grades like maybe a day or two, or maybe at least for a few hours, but you may not be able to do it for those who choose to take the final exam in the night. So that's kind of the downside. But if you choose to take the final in the morning or in the afternoon, you'll have several hours to check your grade and maybe ask me any questions with your grade. So that's good, but there's also the downside for taking the final exam in the night. So I'll see how I get notified about the grade submission date. But if it is indeed due on Wednesday morning, then yeah, I guess Tuesday is the only date for the final exam. And that means on Monday, I'll try to reserve maybe 3 hours or so, or maybe 2 hours just for the Q&A sessions for the final exam. Okay, so that's it for the day. And if you have any questions, just feel free to let me know. Otherwise, have a good day, and I'll see you tomorrow at 10 a.m. for the last lecture.